3.6 probabilities using combinations. So now we're going to take a look at this formula again, where we find the probability of event A being the number of ways that event A can occur over the number of ways that all events can occur in the universal set. So example 1, a university task force of 8 people is to be formed from 16 members of the student government, okay, so 16 students, and 10 professors. Okay, so we're looking at choosing 8 people. So each person is equally likely to be chosen. What is the probability that there's an equal number of students and professors? So what this means is, out of the 8 people, 4 are students and 10 are professors. Okay, and then this happens at the same time. So we have 16 students and we're choosing 4 of them. Oh, I'm sorry, this 4 professors we're choosing. Okay, there are 10 professors in total and we're choosing 4 of them. Okay, and the denominator for this one is going to be, well, how many people do we have all together? So the total number of people is going to be that 16 plus the 10, which is 26. Okay, 26. And we're going to choose 8 of them. And if you take a look at these 2 groupings, so there's 2 groupings of people here, students and professors. All together, there are 26. So those numbers, when added, go together. And we're choosing 4 students, 4 professors. In total, we're choosing 8 people. So we can see that these numbers, you can correspond, and they will, the numbers in the numerator for n will equal the number in the denominator for n, and then likewise with r. Okay, so what is the probability that the task is made up of all student government members? So what this means is that we're still choosing 8 people, but this time we're choosing all 8 students. So we have 16 students and we're choosing all 8. Okay, you can put 10 choose 0 for the professors. Since there are still 10 people, we're choosing 0, but you don't have to, because this will automatically cancel to 1. But if you do like seeing that this 16, again, the 16 and the 10 add to 26, and the 8 and the 0 add to 8, then you can put it in for the organization of it. Okay. What is the probability that the task is not made up of all students? Okay, so what we're going to do here is we're going to use the indirect method. So we're going to say, okay, so the probability of 8 students complement is going to be 1 minus the probability of 8 students. Because 1 for 100%. We are talking probabilities, so the universal set is 100. So 1 minus this up here, 16 choose 8 over 26 choose 8. Now D, what is the probability that the task is made up of either all student or all professors? As soon as we see an or, we're thinking plus. There's 2 different situations here. So case A is the probability of 8 students. And then the second situation is probability of all professors. Okay, so 8 students, well, we have 16 students, we're going to choose 8. Or, so plus, we have 10 professors and we're going to choose all 8 from them. Okay, 2 different situations. The universal set stays the same. It's the same situation in the original question, so the universal set's the same. Okay, and E, what is the probability that at least 6 members are students? So there are situations here, at least 6. So this is probability of 6 students plus the probability of 7 students plus the probability of 8 students. Okay, we can do this in 3 different fractions, or we can put it all over the universal set. So 6 students, so we have 16 students, we're choosing 6, which leaves us with 2 professors. Or, so plus, second case, we have 16 students, we're choosing 7 of them, which leads us to choose 1 professor. Or 16 students choose 8. Okay? And that's all over the universal set. Now, example 2. From a pool of 10 engineers, I'm going to write this down so I don't have to read it again, 7 project managers, and 6 analysts, a team of 5. So we're going to choose 5 people, randomly selected for a meeting. What is the probability that a team will consist of? Okay, so for this one, we're going to go 2 engineers, and at the same time, 2 project managers, and at the same time, 1 analyst. So, engineers, we have 10 engineers and we're choosing 2 of them. We have 7 project managers, we're choosing 2 of them. And we have 6 analysts, we're choosing 1 of them. All over the universal set. So, if we added these numbers all up, so essentially 10 plus 7 plus 6, what we're going to get is 23. So 23 is going to be that first number. Okay, and how many are we choosing altogether? Well, it's the 2 plus the 2 plus the 1. And we're choosing 5 altogether. Okay, so it doesn't matter if we have 2 groupings of people or 3, that n in the denominator is going to be all of the n's in the numerator added up, and likewise the r. Okay, so B, what's the probability that Peter the engineer, so here's the thing. When you read a name saying like Peter the engineer, we're thinking of him as unique. Yeah, there could be 2 Peters engineers, but that's not the case. Don't read too deeply into it. Peter the engineer is just like this specific person. So if you think about Peter, there's only 1 Peter and we're choosing the 1 Peter. Oh, let me do this is Peter. And at the same time, 3 project managers, and at the same time, 1 analyst. Okay? So, sorry, here we go. There's only 1 Peter, and we're choosing 1 of them. You don't need to put this in, but if you think about the rest of the engineers, because we kind of broke down the engineers into normal engineers and then Peter, we would have like 9 engineers left over, and we're not choosing any of them. But you don't need to put that in, unless you want to see all of the n's add up and all of the r's add up. Okay? There's going to be 3 project managers, so we have 7 project managers, and we're choosing 3 of them. And we have 6 analysts, and we're choosing 1 of them. And this is where 1 plus 9 plus 7 plus 6 is going to equal our 23. 1 plus 0 plus 3 plus 1 is going to equal our 5. So that is our universal set. Again, these universal sets are the same. Okay, and C, the meeting will consist of at most 1 analyst. So what we need to do is we need to find the probability that there's 1 analyst, because that's at most, but then we're working our way down, right? So, or 0 analysts. Here's what I would do. So there are 2 situations, we're going to add them. However, it is going to be a very long process if we sit here for the engineers and the project managers and we keep cycling through all the different possibilities. So what we're going to do is we're going to regroup this. We're going to do 2 groupings. We're going to do 6 analysts and then 17 either like anybody else, essentially. So engineers or project managers. So for the first one, we wanted 1 analyst. So 6 choose 1. That means that we're going to choose the rest of the 5 individuals from the 17. So 17 choose 4. And again, that's over 23 choose 5. The other situation is if we choose no analysts. That means from all of the non-analysts, which is the 17, we're going to choose all 5. Okay? I did this one with different denominators. You can also scratch one of these denominators and put it all over 1. That's okay too. Same thing. And you can do that for all of these questions. Okay, example 3, a scratch and win contest at a store allows you to scratch 5 numbers. If all of your numbers match, the winning set of 5 numbers chosen from 1 to 25 without regard to order. Okay, so there's no order. As soon as you see that, you know that we're not working with permutations, we're working with combinations. Okay, so then you win the grand prize. So what is the probability of winning the grand prize? Okay, so what's the probability that we choose all 5 numbers? Okay, there are 5 winning numbers and we want to choose 5 of them. That would be a win. Okay, and that's going to be over. There's 25 numbers in total. And for the universal set, we could have a possibility of 25 choose 5. Right? So there's 25 numbers, we're choosing 5 of them. So that's it for A. Okay? And then B. To win a second prize, 4 of the 5 winning numbers must match. So exactly 4. It's not saying at least 4, at most 4. No, exactly 4 must match. Okay? So 4 match. Okay? So then how do we do that? Well, there's 5 winning numbers and we're going to choose 4 of them. And then there's 20 losing numbers and we're going to choose 1 of them. And that's all going to be over 25 choose 5. If you think about it, for A, this is technically 5 winning numbers choose 5, 20 losing numbers, we're going to choose 0. And if you like to align the 5 and 20 equals 25, 5 and 20 equals 25, you can do that. 5 and 0 equals 5, 4 and 1 equals 5. Okay, and if you did want to calculate this, 5 choose 5 is 1, 25 choose 5 is 1 over 53, 130. Okay, so if you think about Lottery 649, this is kind of like Lottery 525, right? You got to choose 5 numbers, not in any order, out of 25 in order to be successful there. Okay, and here, 5 choose 4 is 5, and then 20 choose 1 is 20 over 53, 130. So 100 over 53, 130. Get rid of that. Okay. Example 4. In the game of Plinko, a disc is dropped into a slot at the top of the board. When it hits a peg, it falls to the right or the left of the peg. As it travels down the board, okay, so state the probability of the disc ending up at each slot in the bottom of the board. So we need to apply probability to Pascal's triangle now, okay? So we have 2 options. The ball or the disc can either lie here or here, okay? And then it can make it here, or it can make it to this opening, or there's 2 ways to get to this opening. If you think about it, we have 1 way this way, 1 way this way to get here. Oh, I wrote 1. I meant 2. Okay, let's keep going. 1 way to get here, 1 way to get here. Okay, I like to do all of the sides at the same time and then go ahead and fill in the middle. So 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Okay, so the total number of roots from the bottom to the top would just be like the 1 plus 4 plus 6 plus 4 plus 1. I get 16. So the probability of landing on A, there's only one root to there out of 16 possible roots to get to the bottom. Probability of B, there are 4 out of 16 roots, right, which is 1/4. Probability of landing on C is 6 out of 16, which I get 3 out of 8. Probability of landing on D, right, 4 out of 16, so I get 1 out of 4. And the probability of landing on E, we get 1 out of 16.